All right, everybody. Very simple lesson here on what I'm going to call X.6. We are definitely changing gears now because we are going to get into factoring. Okay? Uh, so, without any further ado, this is all about factoring out. Get out of there. The heck? This is all about factoring out the GCF. What does GCF stand for? Very good. It stands for greatest common factor. So overall here, maybe I should first and foremost say this. Factoring is sort of like the reverse of multiplying, because factors are things that are multiplied together. Okay, so we want to take all of these polynomials and pretty much write it as a multiplication problem, where these are all the final answers. So again, it's like multiplication backwards. That's factoring. And this first method is called factoring out a GCF. And I want you to write something down. Once again, whether it's on this very handout that you were able to print out or just on separate paper, factoring out a GCF, I want you to write this down, is the first method to always try. In other words, it's like plan A. So here's how it works. Greatest common factor. You look at all the terms you have. Here there's just two terms. And you think, what's between the 12x and the 9, the positive 12x and the positive 9? What is the greatest common factor between those two terms? In other words, what's the biggest monomial? What's the biggest thing that you can divide away from both? Like, what could you divide away from both 12x and 9? And the answer there is 3. You can divide a 3 away from both of those. You can't divide an x along with that out, because whereas that term has an x, that term does not have an x. So you can't divide x away from that term. It has no x. But they both have 3. So what you're going to do is you're going to bring it out in front. Okay? And you're it's almost like you're undistributing, like you're doing the distributive property in reverse. Okay? And so you're going to divide this 3 away from both terms. And whatever's left over, or essentially it's like 3 times what would get you 12x, and then 3 times what would get you 9. And there you go. When you divide the 3 away from 12x, you're left with 4x still in the bubble. And when you divide that 3 away from 9, you still have a 3 left in the bubble. And so now you factored, because this is essentially a multiplication problem, and it's exactly the same as 12x plus 9. And that's what we're doing. Number 2. What's the GCF of negative 30x and positive 5? Okay. Well, you might be thinking 5, but I gotta say something here. Whenever the leading term is negative, it's conventional. It's pretty common practice to divide a negative out along with your GCF. So you're going to have a negative included in your GCF whenever the leading term is negative. That's it. It doesn't matter, like if you look at number 4, I know there's a negative going on here, but it only matters if the leading term is negative. So we're not just going to divide a 5 away from both terms. We're going to divide a negative 5 away from both terms. And so that gets you left with positive 6x. And then what happens when you divide negative 5 from positive 5? That's right, you're left with a negative 1. And so if you ever wanted to check, just redistribute the negative 5 and you should get the negative 30x plus 5. And so you're done. Number 3. Okay. Here's what happens here. 2x cubed, 6x squared, and a negative 10x. What is the greatest common factor? What can you divide away from all three terms at the same time? What do they have in common? Okay. Now, when you look at the coefficients, 2, 6, and negative 10, right? What they have in common is 2, that you can divide 2 away from all those. But look at what else these terms have. This has x to the third, this has x to the second, and this has x, technically x to the first. Okay? Meaning they all have at least x to the first, or x. So you can divide 2x from all three of those terms. And so let's do that. When you divide 2x away from 2x cubed, you're left with 1, because when you divided 2 away from 2, you're left with 1. And when you divide the x away from x cubed, you're left with x squared. In other words, 2x times what would get you 2x to the third, and that's x squared. When you divide 2x away from 6x squared, you have 3x. Again, 2x times what makes 6x squared. And then minus, let's see, when you're dividing 2x away from negative 10x, negative 5, and that's it. Okay, again, 2x times negative 5 is negative 10x. That's how that works. Okay? Here we go. What do all three terms have in common? Well, as far as the leading coefficients, looks like 4. Okay? And there's no negative out in front, so it's just 4. Again, okay? You can divide 4 away from 8. You can divide 4 away from negative 4, and you can divide 4 away from 20. Now, do they have x's in common? That's right. They all have, at the very least, x to the second. Okay? You can take x to the second away from x to the second, from x to the third, from x to the fifth. Maybe you realize that there's a shortcut here. You just go with like the smallest power every time. Even up here, okay? This was technically x to the first. This was technically x to the 0. And the smallest power, it was 0. So, no x's at all. Anywho. When you actually divide this GCF out from all three terms, you're left with 2x to the third, okay, minus 1, I won't even write it, minus 1x, and then plus 5. Again, when you divide x squared away from x squared, no x's, it's technically x to the 0, which is 1. Couple more. Check it out. Negative 2, positive 1 technically, and negative 7. There's no real GCF there, but there is a negative, so I guess we are going to kind of factor out technically a negative 1, right? As a general rule, a GCF of 1 doesn't count, And this is not much better, but I mean, you definitely need to bring out the negative, okay, or a negative 1. Now, do they all have anything else in common? Yeah, they all have at least x to the first. They all share an x, so you can divide out an x from all three terms. So what's going to be left over when we divide negative 1x away from that first term? 2x to the second. See, once again, it's all about negative x, or negative 1x, times what would get you that? Minus x. When you divide negative x away from that term, you're left with negative x to the first. And then when you divide negative 1 away, you're ending up with plus 7. And then when you divide x away, so that's it. Unless you don't want to write the negative 1, which Alright, number 6. You can divide 2. They all have a 2. And then as far as x's, they all have x's. They all have at least 3 x's to lose. So let's divide 2x cubed away from all 4 terms. So what's left still in the bubble? From that term, by dividing, remember we're dividing the 2 out, so 3. And then again, technically it's not that, it's a little weird, but it's not that weird. I haven't said this yet, but when you divide x cubed away from x to the 8th, you're technically, as a shortcut, subtracting the powers. I mean, I'm sure you noticed that by now, but x to the 5th plus 5x to the 3rd minus 2x to the 2nd. And then when you divide 2x cubed away from negative 2x cubed, you still have a minus 1. Alright? No need to turn in these notes, but do the short homework assignment and turn that sucker in.